So the question was, why are electromagnets called temporary magnets? Right? See, other set of magnets till now, what you guys have seen or what you guys use is known as permanent magnets. This is known as temporary magnets. Why is it so? So try to figure out with the help of this video. So what is that we saw? When the circuit was switched off, the electromagnet didn't attract anything, right? But when we switched it on, there was flow of current and this created a magnetic field around it, right? Is it not? And so, thus the compass kind of deflected. Not kind of, it did deflect. But when we switched it off, what happened? So when we switched it off, there was no current and also the magnetic field disappeared, right? So the magnetic field was temporary. It was not permanent. That's why electromagnets are known as temporary magnets. There are a few more properties that we need to know about electromagnets that is not part of your permanent magnets. So next is this video. Again, have a look at the video and try to figure out what exactly is happening over there. So what is that we are looking at? We looked at when we have a current flowing in a particular direction, right? We have a particular orientation of the magnet. That is, we can switch the orientation of the poles, right? We can have north, south. And if we switch the batteries, we can have south and north there. So you can flip the poles, which permanent magnets cannot do, right? Permanent magnets are fixed. If you want to change it, we have to go to extreme length of doing it. Okay, we can't just switch on and off. It's not so easy. It's not convenient, basically. The third thing is we can vary the strength also. So what are the factors that will affect the strength of a electromagnet? Again, have a look at this video and you will get to know the first factor. So what do you guys think the first factor is? Yes, the core itself. The material which we use as the core will affect the strength of the electromagnet. Okay. Sometimes demagnetizing and magnetizing becomes tough if you are using some other material also. Even though it's a it's a very good ferromagnetic material, but it's not suitable for acting like an electromagnet. There are few materials, if we use that, it does not get demagnetized easily. So what core we choose also matters. Okay. So choosing core has to be done in a smart way, not just like that. Now, the next video, figure out what is second factor. Yes, it is your current. So if I vary the current, right, we can vary the strength of the magnetic field. So other than that, we have two more factors. One is the number of turns or the loops, right? How many ever turns you have the wiring. So that will be the strength of the magnetic field. So more the turns, more the magnetic field. They're directly proportional. And after that, it is the wire itself. What kind of wire are we using? Is it a good conductor? Is it a bad conductor? What is the thickness of the wire? Right? Basically, R is equal to rho L by. Okay. So this is your fourth factor. To summarize, I have this write up. So please pause and copy it off.